Hi, hello, welcome to my YouTube channel. I am Aruna, working as an assistant professor in the Department of Allied Sciences RLGNT. So today I am going to explain beta and gamma function. So in this topic we define the functions of improper integrals known as beta and gamma function. This function plays an important role in the applied mathematics. So coming to the definition of beta and gamma function, actually beta function is denoted by beta of m comma n, and it is defined as beta of m comma n is equal to integral 0 to infinity x to the power m minus 1 into 1 minus x to the power n minus 1 dx, and here m and n should be greater than 0. And coming back to the definition of gamma function, gamma is denoted by gamma of n, and it is given as gamma n is equal to integral 0 to infinity x to the power n minus 1 e power minus x dx. So this is what the definition of beta and gamma function. Next we will move on to the properties of beta and gamma function. So the first property says that beta of m comma n is always equal to beta of n comma m. And the second property is beta of m comma n is equal to integral 0 to infinity x power m minus 1 by 1 plus x whole to the power m plus n into dx. This is also equal to for n term. And the third property says that beta of m comma n is equal to 2 into integral 0 to pi by 2 sine to the power 2m minus 1 into cos to the power 2n minus 1 d theta. So you can interchange your m and n. So this is what the properties of beta and gamma function. Next we will move on to the relationship between beta and gamma function. So what is the relationship between beta and gamma function means? That is nothing but beta of m comma n is equal to gamma n whole divided by gamma of m plus n. So now we will prove the thing. See, for proving this we have to go through with the definition of beta function. So what is that? Beta of m comma n is equal to 2 into integral 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 d theta, and you call this equation as equation 1. Okay, so this is what our beta definition. And coming back to the gamma definition, that is gamma n is equal to 2 into 0 to infinity e power minus x square into x to the power 2n minus 1 dx. So this is your gamma n definition. So now similarly here we have taken for n as x variable. So now for m we will take the y variable. So gamma m is also a definition of gamma function only, but in terms of m, instead of x here we have taken the variable y, and you call this equation as equation 3. Next we will take the same gamma definition only, but for the term m plus n. So if you observe here, so for n I have taken the variable x, for m I have taken the variable y, and for m plus n, see this should be r. Okay, so r, that is here for n, here x square is there, I mean the variable x is there. For m I have taken the variable y, and for m plus n I am taking the variable r. So that what, here x power 2n, here y power 2m. So in the place of here n is there, that what, here n, and in the place of m we having here m, and similarly in the place of m plus n, so we should have here m plus n, and you call this as equation 4. So all these three equations were definitions of gamma function. So the definition of gamma function, it's not clearly okay. Now we will move through with the equation 2 and 3. If you do the product of equation 2 and 3, that is gamma m into gamma n, if you do the product, so you will get 2 into 2, that is 4, and integral 0 to infinity, 0 to infinity, and you can see that e power here minus x square, here e power minus y square, the bases were same. If you add the powers and if you take minus as a common, we rest with e power minus x square plus y square, and this is x to the power 2n minus 1, and this is y to the power 2m minus 1 dx into dy. You call this as equation 5. So you call this as equation 5. And as we know that the relationship between Cartesian and polar coordinate is nothing but x equals r cos theta and y equals r sin theta. If you do the squaring and adding of these two equations, if you do the squaring and adding of our LHS, yeah, obviously we will get x square plus y square. And if you do the squaring and adding of our RHS, means we will get like r square cos square theta plus y square sin square theta. And if you take r square as common, means we rest with cos square plus sin square, and as we know that cos square plus sin square is nothing but 1. So finally we left with r square. And also we know that dx dy is nothing but r into dr d theta, and here dx dy were lying in the first quadrant, that what r also lying in 0 to infinity, that is in the first quadrant, and our theta is also lying in the first quadrant, that is 0 to pi by 2. So now we will back substitute all this value, that is x equals r cos theta, y equals r sin theta, x square plus y square equal to r square, and dx dy as r dr d theta, and we will change this dx dy to dr d theta. That means we are changing the Cartesian to polar. Then what we will get? So our equation 5 will changes to, that is 5 equation I wrote once again, that is gamma m gamma n is equal to 4 into integral 0 to infinity e to the power minus x square plus y square, x to the power 2n minus 1, y to the power 2m minus 1 dx dy. So now if you back substitute that, I mean our limit value, that is r equals 0 to infinity, theta values from 0 to pi by 2, and this x square plus y square, this x square plus y square can be written as r square. You can observe here, okay, and our x value changes to r cos theta and y value changes to r sin theta, and dx dy value will changes to r dr d theta. So now what is the next thing means? We will separate r term to as one term and theta as to another term. So now if you see the thing here, it is r power 2m minus 1 and 2n minus 1. Here also r power 1 is there. If the bases are same, is if we simplify, we used to get r power 2, I mean r power 2m plus 2n minus 1, and this is e power minus r square, and sin to the power 2m minus 1, here it should be theta, and cos to the power 2n minus 1 theta d theta dr. And now we will separate r term to one term and theta term to another term as another bracket. And if you see, our first term is nothing but the equation 4, that is gamma of m plus n. And if you see the second term, that is the equation 1, that is the definition of beta function. And if you back substitute that, we used to get this, and you rearrange, so now we will get the required beta gamma relationship between beta and gamma function. Okay, so this is what the relationship between beta and gamma function, that is beta of m comma n is equal to gamma m into gamma n by gamma of m plus n. Okay, in the next video we will discuss the problems related to this. Thank you.